Hello, thank you for watching this video. So this is the part 3 of the similarity series, right? So on this video we'll be doing examples. So I have a few examples that we are going to work with here. So but before we get started, we need to recap from what we did on the previous two videos. So in the previous videos we defined that two triangles are similar if all pairs of corresponding angles are equal in measure and all pairs of corresponding sides are in proportion, right? And then we went on to say that if you want to prove that two triangles are similar, there are three ways in which you can do that. One, you must show you must show at least two pairs of corresponding angles are equal in measure, right? Yes. You don't have to show all three angles are equal in measure. If you can just show that two pairs are equal in measure, that will be enough. The third pair will follow from these two being equal. A second way, we said you must show that all pairs of corresponding sides are in proportion, right? Which means now you must show that the ratio of all pairs of corresponding sides would be equal. Yes. And the third way you can do that, you must show that if you between these two triangles, two pairs of corresponding sides are in proportion, yes, right? Yes. And the included angles are equal. So those are the three ways. Do you want me to write them down? No. One, show at least two pairs of corresponding angles are equal in measure. Two, you must show that all pairs of corresponding sides are in proportion. And three, you must show that two pairs of corresponding sides are in proportion and the included angles are equal, which is their included angles are equal. Those are the ways. So now we're going to be applying that to answer these questions. So I'll draw the first problem and then we do it. So they're saying here, this is example number 1, right? They're saying prove that triangle X, Y, Z is similar to triangle SRT. Can you see? They're saying we must prove that triangle XYZ is similar to triangle XRT. So these are the triangles. So this is this is STR. So we are given that it's 25 degrees. It's 55 here. And then the second triangle, it looks like this. So it's X, Y, Z, right? So this is 100, this is 25 degrees. Are you following? So, you know, we have three ways of showing that two triangles are similar. One, you must show that at least two pairs of corresponding angles are equal. The second way, all pairs of corresponding sides are in proportion. And the third way, you must show that what? You must show that two pairs of corresponding sides are in proportion and their included angles are equal. So in this case, you don't have anything about sides here. So you're only left with angle. So you must show a minimum of two angles are equal in measure, yes, right? If they're saying that, show that these two triangles are similar. So they're saying this angle X is equal to angle S on the second triangle, and Y is equal to R, and Z is equal to T. So what do we have? X, we have X as 100, right? Yes. It should be equal to S if they are similar. Yes. So if you can show that that is 100, then it will be good. Yes. Right? Yes. Then go to Y. Your Y, you don't have Y here. But your Y corresponds to angle R. So it should be 55 if these two things are similar. Yes. And that should be Z. Right? And your Z should correspond to what? To T. So here is your Z and there is your T. So what we can do, we can say, okay, this angle T is equal to angle Z. Yes. And then find either this one to correspond with R or X to correspond to that. Then that will be enough. Yes. But you don't have to find both of them. Finding one will do the work. So how do you do this? It's okay. In triangle XYZ and triangle SRT, Are you happy with this?
Yes.
We can say that our Z is equal to what? It's equal to 25 degrees. This was given, right?
Yes.
And our angle T is equal to 25 degrees, which was also given. We can say, therefore, your angle Z is equal to angle T. They are both equal to 25 degrees.
Yes.
So, what you have done now, you have shown that this is equal to that.
Yes.
So, you have shown one pair of equal angles between the triangles.
Yes.
If you can show a second pair, then now we will have proved that these two triangles are similar. Because if you can show that at least two pairs of corresponding angles are equal in measure, then we're done. So in this case, it's either we have x here and our x correspond to s. So if you can find angle s, we're done here.
Yes.
Or we can say, okay, we have y, which is this, and our y correspond to r. If you can find the value of y here to be equal to r, we're done.
Yes.
So you're fine. So which one do we find? Let's find s instead. So we're given that x angle x, or one find s, right?
Yes.
So we can say angle s plus
T
angle t
plus R.
plus angle r, they add up to 180 degrees, right?
Yes.
This is the sum of angles in a triangle, right?
Yes.
So your s plus
25
t, which is 25,
plus 55.
plus 55, they will give you 180 degrees. So what is s? What is 180 minus 55 minus 25?
100.
It's 100 degrees. So you get that your angle s is equal to
100.
100 degrees. So let's put it in there. But our angle s here is equal to 100 degrees. Can you see?
Yes.
And our angle s corresponds to angle x.
Yes.
And our x was also 100. So we can say, okay, our x over here is equal to 100 degrees. Yeah?
Yes.
Therefore, angle s is equal to angle x, which are both equal to 100 degrees.
Yes.
So we have shown two pairs of corresponding angles to be equal. So it's enough to say those two triangles are equiangular. You don't have to show all three pairs are equal in measure. A minimum of two pairs that are equal in measure guarantees you that all of them will be equal.
Yes.
So in this case, we can say, therefore, we can conclude and say, okay,
Triangle XYZ.
therefore, triangle
XYZ
XYZ
is
is similar to triangle
SRT.
SRT. What is the reason? These are equiangular triangles. So these are two triangles with identical angles. Are you following?
Yes.
Then we're done with this one. So I'm going to clean the board and then we're going to do a second example. Okay, so now we're doing example number 2, right? So example number 2 reads as follows. They're saying AC is the diameter of a circle with center B. D is a point on the circumference of the circle, and EB is perpendicular to AC. So what are they saying? They're saying AC is a diameter of a circle with center B. So B is the center of our circle over here. So this is the center of our circle. And AC is the diameter. So AC here is a diameter. What do we know about diameter? A diameter is a special chord which passes through the center, right?
Yes.
What do we know about the diameter?
It's subtend 90.
An angle subtended by a diameter is 90 degrees. So if this is a diameter, which means angle D here, which is formed by this diameter, is 90 degrees.
Yes.
Are you happy with this?
Yes.
Okay. That's what this thing means. Which is, go and look at the diameter. If it subtends any angle, that angle should be 90 degrees. So angles that are subtended by diameters should be right angles.
Yes.
Are you happy?
Yes.
Now, what do we do? They wanted to say that D is a point on the circumference of a circle. D is a point on the circumference of a circle. That's where our diameter subtends an angle, at point D, right? That's saying EB, this line here, is perpendicular to AC. So what does this mean? It means over here,
It's 90.
it's 90 here and 90 there. So angle B1 and B2.
Yes.
have 90 degrees. No problem. And the first question, they're saying prove that triangle ABE is similar to triangle ADC. So ABE is similar to triangle ADC. Are you following?
Yes.
So there are three ways in which you can show that triangles are similar. One, you must show that they are equiangular. So to show that a minimum of two pairs are equal in measure. Two pairs of angles are equal in measure. Two, you must show all three pairs of corresponding sides are in proportion. And three, you must show that two pairs are in proportion, two corresponding pairs are in proportion, right?
Yes.
And their included angles are equal. In this case, what do we have? We don't have much about sides, but we have some, because if you look here, we just have two sides here, and in this one we only have one side.
Yes.
But maybe you can try something about angles, right?
Yes.
Because look, A should be equal to A, because it's a common angle.
Yes.
So you can see that your A and A are already equal because it's common.
Yes.
And you can see that there's some 90 there and some 90 there.
Yes.
So you should be good.
Yes.
So in that case, to show that these two are similar, we can say, okay, this angle A for ABE, this angle here, angle A for ABE, is the same angle for ADC as well.
Yes.
So in this case, we can say angle A is equal to angle A. Why?
Common.
It's a common angle, shared by both of them.
Yes.
Now, you must show. Now next, can we show that B is equal to D? Yes, B1 is D, and D are equal.
Yes.
Because B1 is equal to 90 degrees, right?
Yes.
Because we're told in the statement that EB is perpendicular to
AC.
AC. And your angle D is equal to 90 degrees. Why? Because D is subtended by a diameter. So this is an angle in semicircle. Are you happy with this?
Yes.
So what does this mean? If your B1 is 90 and your D is equal to 90, which means your B1 is equal to angle D, right?
Yes.
So which means we have shown that A is equal to A and B is equal to D.
Yes. Then
Then these two triangles are similar because we have shown that two pairs of corresponding angles are equal in measure.
Yes.
So let's say therefore, triangle
ABE
ABE
equal to ADC.
is similar to triangle
ADC.
ADC. Why? These are equiangular triangles, which is these are triangles with equal corresponding angles.
Yes.
Go to the second one. What is the second question saying? They're saying, on the second question, they're saying, show that AD times AE is equal to 2BC times AB. Right?
Yes.
They want us to show that. How do we go about this? What is AD? AD is here, right? This side here, which you can see that is this side over here. AE is that side over there, right? On the smaller triangle. And if you look at it, there is it, you can see there as well. BC, 2BC, this part over here. But it's not in any of those triangles.
Yes.
Because it's a portion of AC.
Yes.
Fine. AB is this side of this one triangle. So if you can look at these three, they all appear here.
Yes.
Because there is AD, there is your AE,
Yes.
there is your AB.
AB.
So we can use the ratios of similar triangles that we know.
Oh.
And say, okay, you know what? Because these are similar, we can say AB corresponds to AD, which is equal to BE, which corresponds to DE, equal to AE, which corresponds to AE. Really?
AE and AE.
Something is not make sure. It's ADC.
It's ADC.
Should be ADC. So it should be AC here.
Yes.
So these are corresponding sides of similar
Triangles.
triangles. That's why they're equal. That's why those ratios are equal, because those are corresponding sides of similar triangles. So look now. AD, where is AD? AD we do have
So
it here.
corresponding sides or corresponding ratios?
Corresponding sides. So corresponding sides of similar triangles have equal ratios. That's what you have done here.
Okay.
So AD, there is AD, AE, there is AE,
Yes.
from AB, there is AB. So you're going to work with this
AB.
part and that part.
Yes.
So you can leave this one alone and say, okay, AB over AD is called AE over
AC.
AC. So if you look at that, if you look at this, your AB is there, there's AB, AD is it, your AE, the problem is AC.
Yes.
We must get rid of this AC so that we can try to have a BC.
Yes.
What is AC? AC is the diameter over here.
Yes.
Do you agree when I say that your AC is equal to AB plus BC?
Yes.
So your AC, your diameter is equal to AB plus your BC.
Yes.
So we can say AC is equal to AB plus BC. We can take this straight from the diagram, this one.
Yes.
You don't need to reason for this. But look now, we're trying to have BC in the place of what? Of this AC.
Yes.
There is a BC, which is this. So do you see that your BC is a radius? So this part is equal to this part.
Yes.
So your BC and your AB are equal.
Yes.
So look, you can say, okay, now my BC is equal to AB. Why? Because these are radius. Are you with me?
Yes.
So which means now, your AC now is equal to what? Your BC in the place of AB plus another BC, which is equal to 2BC. I'm not sure if you're happy with this.
Yes.
We're saying AC is equal to AB plus BC. But AB and BC are equal because they are both radiuses.
Yes.
You can see they are both 3's.
Yes.
Because B was told that it was the center.
Yes.
So now, your AC now, you want to express your AC in terms of BC because of what you have there.
Yes.
So which means your AC is equal to BC plus BC. So you've, on the base of AB, you substitute your BC because they are both equal. So which means now, you can take this AC and put it back here. And so, okay, we have what?
AB.
AB
Over AD.
over AD
Onto AE.
equal to AE
Over 2BC.
over 2BC. And then cross multiply. 2BC AB is equal to AE times AD. So which is what we were asked to prove then. We're done. Are you happy?
Similarity.
Now we move to the third one. So they want us to, this is number 3, right? They're saying calculate DC, right? If EB is equal to 2 units. So we're told that EB is equal to 2 units. Actually, they just want us to find DC. So this doesn't really matter. They want us to find what? DC. Where is DC? DC is here. But it also appears there as well. On these ratios, it does appear. Do you see?
Yes.
Where is it?
DC.
This was ADC, right?
ADC.
So it was supposed to be BE over DC. So this was supposed to be DC over here. Because look, it's AB over AD, BE over DC, and AE over AC. So there is a DC. So we want to find your what? Your DC. So do we have AB?
Yes.
Let's first write these ratios first. So okay. AB
Over AD.
over AD,
Equal to BE.
BE
Over DC.
over DC,
Equal to AE.
AE
Over AC.
over AC. These are corresponding
Sides of similar triangles.
similar triangles. Are you happy?
Yes.
In this case, do we have the length of AB? Yeah, we do have AB, it's 3 centimeters. Are you happy?
Yes.
AD, we don't have AD,
Yes.
right?
Yes.
So we don't have AD. BE, do we have BE? Yes, it's 2
We do
units.
have BE.
Do we have DC? DC is what we're trying to find.
Yes.
Do we have AE? No. But AE we can find it because in this triangle, Pythagoras, because it's the hypotenuse of this small triangle here.
Yes.
So we can say we have it. AC, yes, we do have AC. AC is our diameter, it's 3 and 3, so it's 6.
Yes.
So it's this one. So we want this one. So it would make sense to take these two ratios because we know all of this ratio.
Yes.
We don't know that part, or we know that part, or I'm only missing this one.
Yes.
But if you take these two, you see you have two unknowns.
Yes.
You don't want that. You want the one that will give you what you have the most.
Yes.
So the only thing that we're missing there is AE. So we can say in triangle
ABE.
ABE. ABE.
A.
Say that A squared is equal to AB squared plus BE squared. This is your Pythagoras, right?
Yes.
Theorem. And say, okay,
A is squared.
A squared is equal to
3 squared.
3 squared plus
2 squared.
which is equal to 9 plus 4, which is 13. So your AE is equal to the square root of 13. Are you with me?
Yes.
So we do have AE here to be equal to the square root of 13. So which means we have everything here except DC. So in that case, what can you say? So okay, BE, what is your BE then? It's 2, right? It's 2 over your DC, which is what we're trying to find. Is equal to, so we're using this part. Is equal to AE. What is your AE? Square root of 13 over AC, which is your diameter, which is 6. Because AC is 3 and 3.
Yes.
That case, can cross multiply 12 is equal to DC root 13. Divide by root 13, divide by root 13. Therefore, your DC is equal to 12 root 13 over 13. Does it make sense?
Yes.
We're not done here. Maybe we can go to the next example if it is needed. But I think it should be pretty much straightforward. So I can do another one. So let's clean the board and do the example number 4. Or is it number 3? Example number 3. Okay, so now we're doing example number 3, right? So that's saying, given the diagram below, so here's the diagram here, these two triangles, triangle ABC and triangle XYZ, right?
Yes.
So they're saying, is triangle ABC similar to triangle ZYX? So they're asking if these two triangles are similar. So, you know there are 3 ways. 1, at least 2 pairs of corresponding angles are equal in measure. 2, all 3 pairs of corresponding sides are in proportion. 3, 2 pairs of corresponding sides are in proportion and their included angles are equal in measure. So if you look at this, you are only given sides. So angles don't enter anywhere. So you must go and investigate the corresponding proportions. So if they're saying this is similar to that, check this ratio of AB to ZY, and check BC to YX, and check AC to ZX, right? So what do? Let's say AB over ZY. What is your AB here? Your AB here is 15. ZY, what is ZY? Is 5. So the answer is 3. Right?
Yes.
Check the second ratio.
BC.
Your BC to what?
YX.
To YX. Oh, it's YX.
YX.
YX. BC to YX. What is your BC?
Our
BC
base is
is
24.
24. The yx is equal to
8.
is 8, which is also equal to 3. So you can see that two pairs of corresponding sides are in proportion. Is this enough to conclude that these two triangles are similar?
No, we have
No.
to show all of them.
You must show all of them. You must show all three sides all corresponding pairs. All pairs of corresponding sides are in proportion.
Yes.
If it's only two, then their included angles should be equal as well in order to suffice that requirement.
Yes.
Are you happy?
Yeah.
So let's go to the last one, which is the AC. Right?
Yes.
AC over
ZX.
ZX. What is your AC?
This is 18.
ZX 6.
Yes.
This is 3. So you can see that your AB over ZY is equal to
AC
BC over YX, which is equal to AC over
ZX.
ZX. They are all equal to 3. Therefore, triangle
ABC.
ABC similar to triangle
ZYX.
ZYX. By which criteria? Which criteria? What is the reason?
Side.
No, yeah, it's correct. Side, right?
Yes.
But let's say all pairs of corresponding sides in proportion. This is the criteria that we use. All pairs of corresponding sides are in proportion. Are you happy with this?
Yes, I'm happy.
Yeah, they are all equal to 3. Go to the next one. So, example number 4. So I'm going to draw it here. Let's just draw it here. So they're saying here, prove that triangle EAB is similar to triangle BDC. Can you see this?
Yes.
So they're saying that we must show that triangle EAB is similar to triangle BDC. So if you look here, you're not given angles, you're given sides. So you must show that all pairs of corresponding sides are in proportion, right? So in that case, look at your EA over your BD. What is your EA? EA is 39 over BD. Where is BD?
It's 26.
26. Punch this. What is 39 over 26?
It's 3 over 2.
3 over 2, right?
Yes.
So done with this first ratio. Go to AB over
DC.
DC. What is your AB?
AB is 60.
Is 60. What is your DC? 40. This is 3 over 2, right?
Yes.
Let's go to the third one. Is what? Is
EB.
Is EB, which is this one, over that one. Because we started here, over this over that, not this over that. Is EB
DC.
over BC.
DC.
Over BC.
Over.
BC.
It's EB over BC. Oh,
BC.
yes, right.
What is EB?
Our EB is 30.
30. BC
It's 20.
is 20. This is 3 over 2. Therefore, triangle.
EB.
Or we can say what? EA
P
over BD is equal to
AB
AB
over DC
over DC,
is equal to
EB
over BC.
over
BC.
BC. Do you see that all pairs of corresponding sides are all equal to 3 over 2?
Yes.
Therefore, triangle what? EB
is similar
to triangle
BDC.
BDC. What is the reason? All pairs
of corresponding sides are
of
in
corresponding sides
in
proportion. Are you happy?
Yes.
We're done here. Now we have next one. They're saying show. They are proof that what? EB is parallel to DC. How do you show that two lines are parallel? Whew.
Sorry?
How do you show that two lines are parallel?
You have to show corresponding angles.
Corresponding angles are equal. Uh-huh.
And alternate angles.
Alternate angles are equal. Uh-huh.
Corresponding are equal.
Uh-huh.
And alternate angles are equal. Or co-interior angle.
Are supplementary. Co-interior angles supplementary.
Yes.
Or you must show that if you have a triangle, that one line divides the two sides of the triangle proportionally.
Yes.
That's another one. You can see it's the fourth one in this case. So in this case, we're trying to show that EB, who is EB? EB is this line over here. Can you see it?
Yes.
It's parallel to DC. It's parallel to that one. That's what we're trying to show, right?
Yes.
How can we go about this? Look, we proved two triangles to be similar. EAB, right?
Mm-hmm.
And BDC and BDC. Are you happy with that?
Yes.
Look at angle B and C. If these two can be equal,
Angle B1.
B1 and C,
Okay.
you will have
Yes.
equal corresponding angles,
Yes.
right?
Yes.
But look at B of this triangle, which is B1,
Uh-huh.
and C of the triangle.
B.
These are corresponding angles of similar triangles.
B.
Look, it's EAB
Mm-hmm.
and BDC. Look at B of this triangle, which is of triangle. Look at B. What is B of EAB called?
EAB called.
Yeah, because look at EAB. His B is called EB1.
Yes.
And then look at C. C is that.
Yes.
So your B corresponds to C.
Yes.
So they are equal because these are corresponding angles in similar triangles.
Yes.
And if these two are equal, which means this line is parallel to that because their corresponding angles are equal.
Yes.
Do you understand?
Yes, I do understand.
In that case, we can say, okay, look, in triangle EAB and triangle
BDC.
BDC, we can say now angle B1 of this triangle is called angle C of the other triangle, right?
Yes.
Because these are corresponding angles of similar triangles. Therefore, your EB is parallel to DC because the corresponding angles which are these are equal.
Yes.
Because the corresponding angles are equal. We're done. Does it make sense?
Yes, it does make sense. It does make sense.
We have more problems and more and more.
Yeah.
But is it enough now?
Yeah, it's enough. It's
Yeah.
not enough.
And maybe we should stop here. I'm tired. Yeah, because it's all the same from here.
Yeah, the same thing.